head to the Etherpad, everyone, and sign in on line 47 for day 3.
Good morning.
Morning.
I'm just going to have to grab a cable. I'll be right back.
Sure.
Didn't know this. GitHub renders notebooks nowadays. How comes that?
Oh, I think there is some support.
I was just reading some documentation yesterday because that's how I get my kicks, is reading GitHub documentation. And it's like, oh, by the way, we do this thing now. I just thought it was really handy.
Can you send a link maybe on the chat?
I'm going to knock up an example and actually make sure that it works rather than like getting everyone's hopes up. I'll see if I can do something fun.
Well, fantastic. Hello, everyone. If you can sign in. In the Etherpad document, I'll just paste the link in the chat once again. Tony, you've got the wish list at the,
Oh, perfect.
at the top. If you want to just maybe remind people, I think some of the people went for lunch yesterday.
Yeah, absolutely. So I guess, well, hopefully we'll get through most of the material today. So that means we have time tomorrow to effectively discuss whatever you would like to have discussed. And obviously it's quite helpful if I can prepare for it. So in the Etherpad, there's a section that is essentially a wish list. So you can just put whatever you might want to have discussed there, or a +1 to a topic that is already there you like. And then we can do that tomorrow morning effectively.
So I'll just share my screen and show this to people. Am I sharing? Not yet. Here we go. So for people who have just joined us, there is on line 37, there is a wish list of some potential topics that Tony can try and address on day 4 on Thursday after she finishes with a regular lesson. So if you like some of these things to be covered, and if there is time, just put a +1 to the next to the topic that's already there, or add a new one. So there is this line, some simple audio file handling with Wave. And I think, I don't know if everyone noticed, but I think Matt pasted some example code somewhere below below line 159. Matt, do you want to say something about this? So this is using the Wave library.
Yeah, it's also kind of a little bit example because as Tony like adds in more things, it's like, oh, you can simplify that and make it a lot nicer to use. Wave is not the nicest way to do it. And it's also a good example to show, like, just briefly what we were mentioning yesterday is like fundamentally you want to split your problems up. There are Python problems, that is problems that you need to figure out how to do in Python. And then there's going to be your domain specific problem. And then there's actually generic problems like, well, how do you just organize like byte data, that kind of thing. So it's a healthy mix of all 3 of those things. So using waves, you got to be a little bit more familiar with the like how a wave file is handled. You all did your acoustics degrees, so you should be fairly, digital audio, how all that works. But how that example that's there is pretty much how you would do it. But there are nicer things. I'm sure as we do like a little conversation further on that's just talking about your work, then we can recommend some like audio specific libraries. But yeah, what I would say is first try that out and then start picking it apart, get it to break. That's a good way to learn. If you grasp something, is if you get something to work, change one thing and it breaks, then fantastic. You found something that doesn't make sense. And then, of course, I'd say just fire me some questions about it. But it was just a fun little extra tidbit.
Well, that's really great. Thanks very much, Matt. So as Matt mentioned, there is a breakdown of different problems that you'll have to learn. Some are just Python specific, some are just general, how you open a file and read a file. And then more specifically, how you do that with an audio file, and then how you deal with bit data, and then some more specific files to the things to the domain and problems in the domain. So thanks very much. It's all going to remain here in the Etherpad document for you to revisit later on, or just feel free to copy and paste this. Anyway, for those who have just joined us, at the top, you have a wish list of extra topics that we might be able to cover on day 4. So over to Tony now. I don't know if you want to wait for another minute or
Do you
so.
think you could paste the link in the chat again, please, Alex?
Oh, yes, of course. So link to the Etherpad document is in the chat once again, and then sign in below line 47 as always for day 3, and add a wish list of topics, or put a +1 next to the topic already there. Okay, so I'll hand over to Tony. I don't know if you want to do a recap of yesterday or just move on.
Well, yeah, I suppose so. I guess the question is, are there any questions from what we covered yesterday? Because if so, then I would like to try and talk about them now before getting started with the new topics.
I think I have one quick question.
Yeah, sure.
So I was just interested in, I think something you mentioned yesterday, which was I'm interested in the relationship between pandas and NumPy. So is pandas basically just NumPy, but like decorated so that the columns and rows have names? Is that
pretty much? Yeah, I mean it's basically think of it as layers. So at the bottom you have NumPy, and then NumPy has all the functionality you need, but you need to write a lot of code to get certain things done just in the right formatting effectively, because you're operating on rows and columns. So it just kind of helps you to have the right format and have quick operations on rows and columns than you wouldn't have otherwise. Yeah. So it basically just sits on top of it, and yeah, it uses a lot of the functionality. And I think that's a lot how Python packages you can get everywhere are built up. So they build up on different libraries and build additional functionalities that might be exposed in sort of lower level libraries. And then, but in order to avoid having to write, I don't know, 10,000 functions yourself, you kind of just build these wrappers around, and then it becomes a lot easier to do something in 1 line rather than 10 lines, and that saves you time.
Thank you very much.
Does anyone else have anything from yesterday? Cool. So yeah, I suppose yesterday was quite a gentle introduction in general still. So we kind of just covered the very basics of what a variable is, how we assign a variable, what kind of type a variable has. Then we talked about a bunch of inbuilt functions, so how to call them, how to look at the help for them. And yeah, then eventually we looked at libraries. So I introduced you to math. which is quite a low-level library, and then we started looking at NumPy, which is a higher-level library and particularly good for tabular data. And this is kind of where I want to start up again. So I guess we started doing a little bit of plotting yesterday, and that was maybe a tiny bit rushed. So let's kind of step a little bit back and kind of start with the basics of plotting. For that, I would like you to all open up a new notebook so you can follow along, and can you give me your thumbs up or green ticks for when you are ready to go with your notebooks effectively. Cool. So I think I've seen all the ticks now. Is anyone having an issue? I'll take that as a no. All right, I will start sharing my screen. So effectively what I've done, no, that's the wrong stop, sorry, no, it's not right. All right, you should all now see the kind of plot we stopped with yesterday. So effectively what I've done is I've created a new notebook, which is just for today too. I mean, for me, that is just to tidy things up a little bit, and I don't have too much information in one notebook. You can do that as you like. And then I've just kind of condensed the code for the plot we looked at yesterday into one cell. So I suppose we haven't really done that very much, where you can actually have many lines of code in one cell. You don't always have to have just one single line of code per cell. So a brief recap here. We start with the importing the Pandas library as PD, where we use this alias PD. Then we define our data frame by reading it in from this Gapminder Oceania data set, and again using this index column for country, which is the first column in our file. Then this this line here did this fancy stripping of the GDP per cap part of your data frame, so you end up with years, just years, rather than having this extra bit of string there. And then the next line converts the years to the type int, because at the moment years are still a string. And then I can plot the data for Australia. I can now plot the same thing for New Zealand. Okay.
Could I ask a quick question?
Yes.
Every time I've tried to do that data.locaustralia.plot, I've had to run the cell twice. Is it, am I just not waiting long enough? Because it comes up with a little matplotlib.axes blah, 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 blah message where you've got axes subplot. But then if I run it again, it then plots underneath it. Is that just something with me?
I don't know. I would have to look at it, I suppose.
I don't
it's
think
possible
it's
that it takes some time. Sometimes it takes some time.
I mean, if it's thinking about it, you always have like the little star next to the cell, and once you have the little the number, it means it has run it successfully.
Okay.
But as long as it does run, I suppose that is.
Yeah, I don't think it's the end of the world. So.
Yeah. Okay.
We'll just carry on. Thank you.
I mean, we can have a quick look maybe in the coffee break or something to diagnose it if you want, if you're really curious. But so out of just the description, I don't think I can diagnose it effectively.
Sorry, I'm having an error as well. So in the line data.columns equals years dot as type int, I'm getting an error from that, and it says cannot cast index to d type class int.
I have the same error.
Oh, that's good to know.
Have you done the index col equals country in your first call?
Yeah.
Index. Oh no, I missed that one. Thank you.
Yeah.
I also have that problem.
But everyone manages to get to.
I'll try it again now.
To the plot.
Okay, it looks like that's fixed it. Thank you.
Cool. Fantastic. All right, so this, I mean, effectively this demonstrates quite high functionality of pandas. And pandas again builds up on not just NumPy, but also a plotting library called Matplotlib. And rather than using this fancy built-in pandas way of plotting, we're going to now just use Matplotlib on its own. And for that to work effectively in a notebook, you start with something called a magic command, and that is signified by this % sign. And it's just matplotlib inline. And basically what that tells the notebook to do is to put all the plots we've seen, like this one, into the notebook rather than for it to pop out as a separate window. And then we want to actually import Matplotlib because at the moment we've only imported pandas. And again, Matplotlib has a typical way of using an alias. So that would be import matplotlib, matplotlib dot pyplot as PLT, and using this PLT is pretty standard. So if you go on your Stack Overflow, that's kind of what everyone uses. So how do we create a plot like this one without using a pandas data frame? So we need to define a data set we want to plot. So I know this is a bit cheeky because effectively what I'm going to write down now is a list, and we've not really covered lists yet, but that will come later. So here's a sneaky peek on how you define a list. So time, and you indicate it by using square brackets, and then you just separate values in that list by a comma. So now you have, say, an x-axis, and now we want to define a y-axis, call that position, and 0, 100, 200, and 300. And now we want to plot this. Here for the pandas, we could just go data.plot. We can't just go time position.plot. That doesn't work, but we can pass the list of time and position to the plotting function. So plt.plot, and let's have a look at what the help says. Plot y versus x as linear and or markers. So you definitely need y. You can pass an x, and then you have all sorts of additional arguments. But the sort of simplest example here is x, y, and then you get a plot. So our x is the time, and our y is the position. And we get this lovely straight line. What we can now do is play around with the plot and make it, well, let's have a look at where the data points are. So I can say I would like to use a marker to be a circle. So now I have my data points as circles. I could say I would like I don't actually want the line, I just want the points. So I can say something like line width equals 0. And
just
now,
a quick question, Tony, is that a lowercase o for the marker? Just
it
to
is
make
lowercase o, yes.
Okay, good.
So you can also use things like a triangle and various other symbols. I think star also works. So if you use something like line width equals 0, you get rid of the line. You can change the color by saying color equals red. And now you end up with red stars. So there's a lot of customizability, and the easiest way is to go and read the documentation. The other thing you might be interested in, particularly to start out with, is, well, as a scientist, you probably want labels on your axes and not just some random numbers on a plot. So it is quite straightforward to add some labels to this. So again, using this PLT alias part, you can say X label is time in hours, and PLT Y label is position in kilometers. And now you have your X and Y labels. Matplotlib is a very large library with a lot of functionality and a lot of ways to customize your plots. If you were to use Matplotlib in a script that isn't part of a notebook, you would typically have to explicitly call plt.show in order to actually display the plot. And that would then make it pop out effectively as the window with a plot in. But because we're using this inline argument and are in our notebook environment, we don't actually need the plt.show command. You might want to use it if you are using multiple figures, but that is not something we're going to explore right this moment. Yeah, so that is the very simple way of plotting with Matplotlib. Let's have a look at how we can explore more of the pandas plotting, because so we've now learned, okay, we can customize plots with Matplotlib, but how do we plot, say, both New Zealand and Australia in one plot using the pandas plot? So an easy way to do that would be to, let's go back to so data is still, I'm gonna give it a heading actually. Back to so data is still that data frame we've defined earlier and we've plotted, and let's have a look at plotting the two data series in one plot. So if I use the transpose of data, I can now plot both Australia and New Zealand in this plot, and I can also interact with this plot in the same way as I interacted with this plot by saying plt.ylabel is GDP per capita, and I can add an X label and say years. Helps if I spell it correctly. There we go. What is nice about the inbuilt functionality of pandas plotting is that you actually have multiple types of plots available to you in a very simple way without really having to go and write a lot of code. So again, it's this whole idea of, oh, you have pandas sitting on top of Matplotlib that hides a lot of the complexity of the plotting and makes plots look nice. So one way to do that is the plot style ggplot. So that would, so you can say that you want to set the plot PLT, so the Matplotlib style, use ggplot, and then we're still plotting Australia and New Zealand in one plot, so same thing, but now rather than just saying we want to plot it like this, we can actually define that we would like to plot it as a bar graph instead of lines. So I can say, okay, I would like a kind bar graph, and now I have effectively plotted exactly the same type of data, but as a bar graph in one line. And again, I can still set my label as GDP per capita. And it kind of works in the same way. You can obviously also use the plot function from the time and position example we used. So how do we actually get the data out of pandas in order to use the plt.plot xy example we used before? So well, we need to define our x and y's from our data frame. So years we can define as data.columns, and we can say GDP Australia is data.log and then Australia. And now we can just use the plt.plot function and say x against y, so years against GDP Aus, and say I want a dashed line style, so I don't even need to specify a keyword here. I can just use a dashed, so two dashes effectively to indicate a dashed line, and say I want it in green. And now I end up with this dashed line in green. If we wanted to plot Australia and New Zealand together, we need to expand this a little bit. So you can see how I end up using a lot more code than I would if I just used the inbuilt functionality of Matplotlib. So I've defined my Y series for Australia, but now if I also want to plot New Zealand, I need to define that as well. Same idea. New Zealand. And now I've plotted my one line. I can now add a second line where again I plot years against GDP New Zealand. And now I want to maybe use a blue continuous line. And I can also give them labels. So I can say label equals Australia, and this equals New Zealand. So at the moment, I've defined a label, but I can't actually see the label. So in order to actually show the label and have a legend, I need to explicitly define that. So I'm gonna create legend. And again, you use the legend functionality in Matplotlib, so plt legend. And if you have a look at the documentation here, it doesn't really give you massively helpful things. It just tells you, oh, you can put lots of arguments in there. Well, that's great. So one thing you might want to set is maybe the location. And yeah, you can see, you can kind of see a lot of information you can pass. So one of the things you can pass is this LOC parameter. And here's a nice little table that tells you that the best location is 0, upper right is 1, and so forth. So let's try upper left, which would be 2. So I can say loc equals 2. And then I can still have my labels. X label is years, and Y label is GDP per cap. And now I have my legend here on the top left. And if I play around with this, so 1 should be top right. Obviously that is inconvenient because it now prints it over the line. And if you don't pass any location, it will just try and figure out the best one. And in this case, top left seems a very good spot. So at the moment, we've looked at using this plotting method. And I showed you that if we set the line width to 0, we effectively get a scatter plot. However, there's also a scatter plot functionality in Matplotlib, as well as actually in Pandas. So let's plot the New Zealand and Australia per capita GDP against each other. So rather than saying plt.plot, we can say plt.scatter and say GDP Aus versus GDP New Zealand. And again, you can look at the signature. So here you can see that you have an X and a Y. You can set a marker. C is the color. S, I don't actually know. Oh, it's the size of the points you use. CMAP tells you something about the color. Alpha is whether you use 100% color or how transparent it is. And again, there's a lot of information just in this documentation to have a look at what what each of these bits are. So if we now
Tony, sorry, Tony, can I just stop you for a second? So we have some people who got a bit behind with the code, and we don't actually have the code in Etherpad. So would it be possible to, no, it's fine. Would it be possible just to copy maybe things from the top where you imported the file so that some people can catch up?
Sorry, if you, can you, I mean, I know you've put this in the chat. I don't really see the chat. So if you speak up, that might be easier because otherwise I don't see it.
Feel free to stop. So this
Please
is going to go into Ether.
Fast. This is, I mean, the whole point is that you can follow along.
So this code is now going to show up in the Etherpad so that people can copy paste if they missed something.
Yeah, so plotting. So which bits in particular do we want? So the position bit is there, right? So then we have this. Then we have the ggplot. Then we have the very fancy Matplotlib with lots of code. And then we are at the scatter bit.
So now it's in Etherpad online.
Yeah.
Which line is it line 70?
It's from line 75 onwards is what I copied. So these are the plot where I plot both Australia and New Zealand in one go with the labels. Then the next one is the ggplot style one. Then the next one is this same plot as before, but using the Matplotlib functionality rather than using pandas for plotting, and introducing legends. And then the last thing is when we started talking about, and you need to import the, hang on. Yeah, so you need to import this as well for the Matplotlib plotting.
So that will have to go before.
Yeah, so before you do any plotting, you need to use this magic command of matplotlib inline and then import matplotlib.pyplot as PLT.
So this is to show the graphs in line in Python notebook. And I think there was a comment in the chat as well. Someone asked whether this is going to work in a Python script that you run from a command line. And the short answer was no.
Yeah, so you wouldn't use the %matplotlib inline. In fact, if you put that into a script, it will throw an error, be like, oh, I don't understand this. Why are you putting a % at the start of a line? This is not Python.
Yeah, so from command line, you would typically either save your graph into a file, or I think people who are more experienced with Python, Sam and Matt and Tony, I think if you run it from a Python console, it might actually pop up the graph in another window as well in the command line.
Yeah, so you would typically use this plt.show with brackets, and that will pop it out as a window. And if you don't use that, if you don't use the .show thing, you can use something called savefig. And I think that is one of the exercises for later, is for you to try and actually save a plot rather than just have it in the notebook.
Can I ask a quick question?
Absolutely.
Actually, I forgot to write %matplotlib inline, and it seems to have worked anyway, so I don't know.
I think it's because of pandas, probably, because I think pandas does some fancy imports under the hood.
Okay. What I was just going to ask was just about sort of this concept of overlaying plots, because you've sort of plotted a line and then you've plotted another line and it's overlaid it, which in MATLAB, which I'm more familiar with, and I guess probably most people are, there's this whole sort of idea of hold on, hold off, and which figure are you plotting on and what's your current figure and that sort of thing. I mean, how's that work here? Are they just, is it anything in one of these Jupyter cells will kind of all refer to the same plot, or?
Well, so you can manipulate. Yes, the short answer to that is yes. The long answer is you can be very specific as to which plot you plot what into. So you can define a figure environment, you have access to your axes, and you can specifically say which axis you want to plot on. You have subplots as well, so you have multiple small plot windows, and then you can define which axes and those you want to plot on. But rather than having this hold on, hold off, you specify the axes you want to.
Okay, so it just overlays by default unless you clear it or something.
Yeah, so there's, yes, unless you do something clever, it will just put it all in the same plot.
Okay, thank you.
And I think everyone is now up to speed with the code, unless anyone wants to ask anything.
If you have any more questions.
How about if you wanted to export one of the figures as a graphics file or something to then put somewhere else?
So I think that is one of the exercises you'll be doing as part of this section. So you can explore that yourself, and I'm happy to discuss it after. And we're also actually almost at the exercise section. So I have one more thing to show where basically so this is the Matplotlib way of plotting it. How do we plot this with pandas? So we again use this data transpose dot plot, but rather than just saying dot plot, we actually say plot dot scatter, and then say X equals Australia and Y equals New Zealand. Apologies for my mix of use of quotation marks. I use them quite liberally. So now you effectively need to specifically say which column header, or row header actually in this case, because you're doing the transpose, you would like to plot against each other, and then you end up with the same plot, but it also automatically already puts your labels in there, which you don't have in the original, where you would have to explicitly say what your X and Y label is. I mean, I suppose from my personal experience, I tend to actually just use Matplotlib plotting functionality rather than using the pandas plotting functionality, because mostly I'm not as familiar with the syntax. So I would need to Google a lot more in order to get my plots working. And then sometimes I want something very specific, and that can't be done in pandas. But if you want a quick and dirty plot, then it's a great way of getting an idea of what your data looks like. And this actually gets us to the exercise section of this. I'm gonna copy the code, the link to the exercises into the chat. So yeah, so there's a bunch of exercises on minima and maxima, and playing around with tick labels and things like this. And then there is a section on saving your plot to a file. So this isn't an exercise yourself. No, it's not an exercise per se, but it kind of gives you an idea of how you can save it. So basically try it out and see whether that works for you. And then I'm happy to talk about that once we've kind of dealt with the exercise section. I'll give you 10 minutes for the exercises now. So I'll start up again in like at 9:55. But feel free to ask me questions as you are doing the exercises.
Hey, can I ask a question?
Sure.
See, when you were doing the bar chart plots above
Mhm.
the GDP, I was having just some trouble. I was trying to catch up as well. But when I copy over from the Etherpad and just copy and paste and run the code, I actually get an error message, but I'm not really sure why. Could I share my screen?
Yeah, sure, please do.
Let me just make you a co-host. And while Tony is helping that, this is a question for David Hara. If you're having any problems, I know you joined us a bit late. If you're having any issues, please just speak up, and we'll try and help you.
So, do you see the error?
The attribute error part?
Yeah, so now the whole point, the whole lovely thing about Python is learning how to understand reading the error. So it points at the line 1 and it says years equals data.column. And then it says data frame object has no attribute column. The reason is because it's not column, it's called columns. So there's an S missing at the end.
Right, let's try that.
No. Don't read the error. So now it says key error, Australia is not found. So you're using round brackets for your location. So it's lock and round brackets, but you should be using square brackets for this.
Square brackets? Okay.
Yeah. So yeah, things need to be very precise. And effectively, the reason I think you're using square brackets for this is because you're accessing a location in an array. And in order to do that, the syntax requires square brackets. Try and run the cell again. So name plot is not defined. So again, look at the line. It tells you which line the issue is.
Number 6?
Yeah. And it's the one where you plot New Zealand. So yeah, there you go.
Hey, right.
And this is how you debug your code effectively. I mean, Python does tell you what's wrong with it. Sometimes you might not know, like it pointed at the thing saying like, oh yeah, data frames does not understand column. And then you're like, And my go-to would then be like, oh, what should it be? Either I'm going to Google or I'm going to actually hitting tab on something will tell you. So if I use something like data.column, so if you hit tab, it will autocomplete to the right thing. Or give you multiple options.
Cool, awesome. Thank you very much for that.
No worries. with the exercises? Are there any questions? So just to briefly talk about the save figure part. So in theory, if I have a plot like this, I can just add a line saying plt.savefig and then give it a name, my figure.png. And that should save a figure. And oh, hang on, I'm not sharing my screen. I'm so sorry. So yeah, what I did just now is add this line to this plot here, plt.savefig, and then my figure png, and this figure does appear as a saved file now in the directory I'm currently in. So that's probably not the best directory. I probably don't want it in notebooks, so I probably would want it in something like analysis, or I don't know, basically in a place that is separate from where you keep your notebooks. Does that work for everyone, the saving the figure? All right, I'm gonna take the silence as a yes, and we'll continue with a different topic. So if you do have any questions about the plotting, feel free to ask them later still, or in a coffee break or something like this. I did forget to mention we're having the same coffee breaks as yesterday. So yeah, the day plan is basically identical to yesterday with 2 breaks, and we should be done by 1 the latest. All right, so the next topic we're going to discuss is lists. So lists are a way to store multiple numbers of the same sort of type in an array or in a container effectively. And we've already cheekily have written a list when we wrote the positions and time. So I think most of you being MATLAB users, you obviously know why you would want to use a list in order to not give variables names like pressure 1, pressure 2, pressure 3, and just have very clunky code. So the way lists work in Python is that you use a square bracket to define the content of a list. Values are separated by a comma, and a list has the built-in function length can be used on a list. So I can define something like pressures equals 0.1, 0.21, 0.24, 0.25. And now this initializes my list with a bunch of numbers in it. So I can look at the type of pressure, for example, and it tells me that it's a list. I can look at the length of pressures, and it tells me that it contains 4 items. So as we said yesterday, Python starts counting from 0 in order to get the first element of a list. We again use the sort of square bracket notation we also used with pandas to get the 0th index. So print first item in list is actually pressures 0, and that gives you this value back. You can replace list items by reassigning them. So I can say pressure 1 should be 0.3. So at the moment it contains 0.21, but I can now pressures typo. I can now reassign it, and if I look at pressures, I now have a second element that is 0.3 and not 0.21 anymore. You can add things to a list. So let's define a new list called primes. And we have 2, 3, 5. And I want to append the next prime. I can print primes, and then let's say primes dot append. The next one would be 7. Print more primes. Will now first print me the original list, and then I have just added the 7 to the end of this. Append is a method or a function because it has the brackets, but it belongs to lists. So all lists have this append method available to them, and methods that belong to objects are usually called in exactly this way, where you say primes dot something. And in fact, we have seen this a lot in the plotting. So the dot scatter is a method that belongs to the data frame or is accessible from the data frame. Then if we want to figure out what is available to a list in terms of sort of your built-in functions, you can say primes dot and then hit the tab button, and then you see all of these append, clear, copy, extend, pop, remove, reverse, sort. So these are all functions that are available to operate on the list. You can also use the help. That gives you the same information plus all of these double underscore functions, which are these kind of member variable hidden functions you shouldn't necessarily use. So extend is similar to append. So if we actually, I'm just going to get rid of the helps thing again. So primes dot extend extends a list by appending elements from the iterable. So extend is effectively append, but you can append a other list to it. So I can say something like middle primes equals 11, 13, 17, and 19. And I can now extend primes by adding middle primes to that. And I can look at printing primes beforehand and afterwards. So now I've just have the original primes list, but with even more prime numbers in there. The next question you might have, how do I remove something from a list? You can use the del function, and then you use the index. So if we, oh no, I missed a prime. So let's go with primes dot append and say 20. So now I have a 20 that isn't a prime, so I want to remove that. So I need to find the index. One way of doing it is, so I obviously know what the length is. So it's 9. My 8th index will be the 20. Primes of 8 is my last index. I can also do a cheeky one and start counting from the other way and say -1. That will give me the same index. So I can either index from left to right, starting from counting 0, 1, 2, 3, and so forth, or from right to left, where I start with -1, -2, -3, -4, and so forth. So going to the actual deleting part, I can now say del primes 8, and that should remove the last entry in my list. So let's have another look at this. And yes, indeed, the appended 20 is gone. I could also now remove something in the middle. It doesn't have to be the end. So any index in that list can be removed. You can define an empty list. So when I first defined primes and I've defined pressures, I didn't really, I already specified entries in it, but I can also define an empty list and say my list equals empty. If I now look at my list, it's an empty list, but I can look at the type of it, and it will tell me that it is a list. Lists don't really necessarily have to just contain numbers, so you can totally mix different types. So you can have strings and floats and integers in there. So let's say my list dot append, or let's go with extend, and I'm just gonna put something like 1, create goal, create list, sorry, 2, extract item from list, 3, modify list. Excellent example of syntax error. So here it tells me, ooh, I'm missing a comma. so it doesn't really understand what's going on. My list should now have all of these items in here. And indeed, the empty list has now been extended by this lovely list I defined in here. So I think what was briefly asked about yesterday was mutability. So mutability means, can I assign something after it's been created effectively? So if we remember from yesterday, we defined a string. And we've looked at the first letter of of element is C. So this is very similar to looking at my first entry in primes. So that would just be exactly the same syntax, apart from I need a comma. And then here we have my primes list, so that's the 2 up there. However, if I try and change the 0th element of my string carbon, I cannot do this. If I try and do something like element 0 equals capital C, I get the error, string object does not support item assignment. And that basically means it's an immutable object. It cannot be changed after its creation. Whereas if you have a list, it's a mutable object and they can be modified in place. The last thing, so there are 2 other types of collection in Python. They're called dictionaries and tuples. I don't think we're going into the details of these, but effectively tuples are pairs that are immutable, whereas dictionaries contain pairs of keys and values, very similar to what you've seen in your pandas arrays, and there you have some flexibility to modify things, so they're not the values are not immutable, so you can change them. Okay, so I think, yeah, the last bit is how do I break my list? So if I want to access an element that doesn't exist, I get a lovely error. Print 99th prime is primes 98. It tells me list index is out of range because I actually only have 8 prime numbers, or 7, no 8, I think. My primes list is actually only 8 characters long, so I cannot access something that doesn't exist in the list because the list isn't long enough. I think that's everything useful to know about lists. There's maybe one side note. Lists are different from NumPy arrays. This is not something that is necessarily covered, but we could briefly talk about it tomorrow. So you might have to convert between certain types of arrays that exist, and lists are sort of the most basic collection of items you can put together. We're going to go into a coffee break now. So I encourage you to actually take a break, stand up, use your shoulders, get a tea or coffee or water or whatever you like. And we'll reconvene at 10:30 and then basically go straight into the exercises for the list. But I'll announce that when we get back after the break.
Okay, so we're back at 10:30. I'll make a slide. And then David, if you want to stay behind, so we can maybe help you get up to speed.
Hopefully everyone's back. I see you're still troubleshooting.
Yeah, we might need to move for a breakout room. Sorry, Tony.
No, that's totally fine, because I would encourage everyone to basically just now look at the list exercises. So I'll just paste that in the chat, and then where's the chat? Yeah.
I will also try and send Matt and David to a breakout room.
So have a look at those list exercises. See how far you get. I'll probably restart at 10:40 with the next topic.
Sam and Shashank, you don't have to go to the breakout room if you don't want to.
How's everyone doing? And what is the status of the breakout room? Cool. Are there any questions? I'm just going to carry on, and please do let me know if you have questions. And I'm guessing people are still trying to resolve things in the breakout room. But yeah, so the next topic is loops. This is fairly similar to MATLAB. So I would imagine we can get through this fairly quickly. So how do you loop over data in a list? Well, the syntax looks like this. So you have for number in 2, 3, 4, 5, print number. So that is the equivalent of basically writing print 2, print 3, print 4, print 5. And what we get printed is just each element of that list. So a for loop is made up of a collection, a loop variable, and a body. The collection is the list in this case we're looping over. The loop variable is the number. So every time you effectively assign number equals to 2 as you loop over it, and then you have the loop body, which is signified, which in this case is here just the print number. Python works with indentations rather than brackets and semicolons, such as other languages. So if you use a notebook or an IDE, it will automatically indent in the right way. What you would typically have is 4 spaces for the indentation. And your IDE, if you put a colon there, will automatically figure that out normally. What can be a bit tricky if you use a very simple editor, be careful to not mix your indentations between tabs and spaces. Often with editors, you can show hidden characters so they can tell you whether you're using a tab or spaces for your indentation, and they must all match. So if I were to do something like this, I will get an error saying that there's an indentation block expected. If I do something like this, it will run it, but it's quite uncommon to have just 2 spaces. So if I were to have another argument here, say variable equals number plus 3, something like this, and then I want to print var, but I don't have the right indentation level, I get an error, because even though I'm only using 2 indents here, this is perfectly fine, but then suddenly in the next line I use 3 indents, and then Python is very unhappy. So I think the safest option is really always to use your 4 indents, and then you have a very successful way of writing your loop. The indentation is also true for other situations. So name John and last equals Smith will not work. And again, give you that indentation error that there is an unexpected indent, because that is how Python understands different code blocks. If you're familiar with loops, you know that a loop variable can be called effectively anything. So it doesn't need to be number or I or something. It would be perfectly fine to write something like 4 kittens in 2, 3, 4, print kittens, and it will still print exactly the same thing as before. So I kind of showed this already. You can have many things in the body. So you can have, I don't know, 20, 30 lines of code in your for loop. So it doesn't have to just have consist of one line that prints something. If you want to not explicitly have to count over a range of numbers, such as here, you can use a built-in function called range, which produces a sequence of numbers. That is very useful. So I could do a for loop in the following way. For number in range 0 to 3, print number. And then again, I get 0, 1, 2. I can also do 7 to 20 and a stride of 2. And then I go from 7 to 9, 11, and so forth. So range doesn't have to be incremental. You can also define what the stride integer is. A common pattern for loops is to use an accumulator to count something that happens in a loop. The syntax for this is, I think, very similar to MATLAB. So you would define a variable and set that to 0 at the start, and then for number in range 10, you can say total equals total plus 1. So every time in the loop, it will add 1 to the total. And I can then print the total at the end, and yeah, it always adds 1. We could make this a bit more interesting and say, we say total plus my loop variable plus 1, and then we get a 55. So each time we add the number that comes out of my range in the for loop to make up the 55 at the end. And you can see in the printout, it's not necessarily clear whether you're printing something within a loop or outside a loop. So if that is important to check whether something happens in a loop, you can put a print statement to that effect. Yeah, and that kind of gets me to the end of the for loop section. So there's a few exercises to go with that, and I would quite like to probably not spend too much time on these. I have pasted the website into the chat, so you can have a look at these exercises. and yeah, have a go and see how you get along with your for loops in Python, and let me know if you have any questions. How's the breakout room working out?
It's good. It's good. Mainly we had problems with syncing with Dropbox. Because everything was in Dropbox and then just symlinked from its machine. So we had to drag everything first to the local drive. But now we've got Jupyter Lab up and running.
That's good.
So it's good.
All right, I'm going to carry on, even if you haven't finished all of those exercises, just to get onto the topic of conditionals, the other main way in which we can break up programming flow and use probe different blocks of code to do things. Are there any questions around for loops, or is it okay? Is everyone fine to start with if statements? Great. Fantastic. So this is going to be conditionals, which again, I suppose if you are seasoned MATLAB programmers, you know what an if statement is. And it kind of helps you control whether a block of code is executed or not. So the structure is very similar to that of a for loop, in the sense that we can write something like mass equals 3.54. If mass is larger than 3, print mass is large. And let's reassign this variable to 2.0 and use the same if statement, 3.0 print mass is large. So my expectation would be that the first block, the print statement will happen, and for the second block, the print statement will not happen. And this is exactly what the code does. So if I set the mass to 2, it's not larger than 3, so therefore this part of the code does not get executed. Also note that you have a very similar structure to for loops. So again, you have a body that contains the statement that you're trying, like the code that you're trying to execute, based on the condition being met or not. If you use an if statement, again, you use a colon to end that line, and that will also tell Python that you need your 4 spaces indentation. So obviously the example above is kind of very contrived. So we might want to test a list and see whether numbers in that list are larger or smaller of something. So essentially we can now mix an if statement with a for loop. So rather than just having one mass defined, we can define a list as masses, 3.54, 2.07, 9.77, 1.86, and 1.71. And then we loop over these masses. So for m in masses, if m larger than 3.0, print m is large. I will also put that in the Etherpad. So if we now execute this code, it will loop through my list of masses and it will check each time if each element is larger than 3, and there's obviously 2 elements that are larger than 3 in this list, and those are exactly the ones that get picked up. So that is nice and simple, but what if you want to do something with the other parts of the list? You have a else statement. So you can effectively take 2 branches, or multiple branches, in fact, where you have a first if statement, and if that condition isn't met, you can say else I would like to do something else. So else is, oops, that was accidental. So I can't use the else in the same code block as if, so I go back my 4 spaces and type else, and again using the colon, I indicate I'm now in an else block, and I can say print m is small. And now I have a perfect assignment of the array of whether it's the masses are large or small in my printout. So as I said before, you can have not just one condition and one else. You might want several choices and have a test for each of this choice. And for this purpose, you can use the elif statement. So I'm going to modify this example a little bit further. So if my mass is larger than 9, I'm going to say m is huge. Then I'm going to introduce a new conditional, elif, again using the colon at the end, but I want to have a condition here. So m is larger than 3.0. I can print what I printed before, so m is large. And then I can still keep my previous else statement saying everything else is small. So if I again execute this, I can identify my very large mass as huge, and the other ones are assigned as before. What is important is that conditionals are tested once and in order. So you don't go backwards on it. So you step through this test, and that's it. So ordering your if statements matters. Let's look at an example, grade 85. If grade greater or equal 70, print grade is C. Then elif grade is greater or equal than 80, print grade is B. And elif grade is greater or equal 90, print grade is A. So what happens here is that 85 is larger than 70. So this first if statement will be executed, and we won't even get to this second if statement. So even though the grade should be B, the way we ordered this, it will make the wrong assignment effectively. And it does not automatically go back and reevaluate things. So the other thing is also, if you change your velocity, if you change a variable value, if you reassign the value of a variable, then it does not automatically go back, readjusting this. So I'll give an example. Velocity equals 10. If, actually, let's call it vel, so I don't need to type quite as much, and call it if velocity is larger than 20, print moving too fast. Else, print adjusting velocity and val equals 50. So if I execute this now, it will execute the else part because we are smaller than 20. However, it then doesn't go back to the if part where it would print that the velocity is too fast because we're now at 50. So in order to kind of play around with this a little bit, we can construct a loop that is executed 5 times where we adjust the velocities based on the decisions made within the if statement. So say we're combining again the for I in range 5. So we're doing 5 loops. And then say something like print I vel. So we're printing the velocity and I'm not printing it properly. This is the first thing we're doing. So at the moment, the velocity is always 10 because we're effectively having a for loop and then the if statements outside of this for loop. So let's move them into the for loop. So I can just indent this here and print this part as well. And every time we're moving too fast, I can say vel should actually be vel, the velocity minus 5. So we're actually slowing down when we're going too fast. And then let's move the else statement into this for loop as well. And rather than saying adjusting velocity, we can say moving to slow. And we increase the velocity by 10 every time the else statement is executed. And then we can say print final val is the velocity. And now executing this, I'm stepping through my loop, start out with 10. So that's my first iteration. Then I'm too slow. So I'm adding 10. Now I am at velocity 20. Velocity 20 is still smaller than, for the second time, that still doesn't get executed because it's only if the velocity is larger. Then we're moving to a velocity of 30. Then the if statement gets executed. We're now moving too fast and we're slowing down by 5 and we're slowing down by 5 again. And then the last loop, we're again not reaching the if condition, but going into the else else part of the block. And that's how we end up with a final velocity of 30. So sometimes it might be quite difficult to understand how complex relationships work with rather complex if and else statements. So I tend to use a lot of sort of print statements to kind of figure out what's going on. The other thing is you can do a lot of sort of testing of statements, and yeah, so there's a lot more scope around if statements, which we're not really touching on. So effectively, when we discussed data types, we only talked about int, string, and float. However, effectively, what the if statements is testing is whether something is true or false. And this is a fourth type of a variable, which is called a Boolean variable, and can have two states, essentially, whether a statement is true or a statement is false. You can also test multiple things at once. So you could test something if if something is true and something else is true, or you can test whether something is true or something else is true. So these are conditional operators, which I'm gonna assume that you have encountered them in MATLAB, and they do exist in Python as well. Are there any questions with regard to conditionals? Cool. I think in that case, I would like you to attempt the first exercise in the conditionals and leave the other ones. I'm gonna copy and paste the link into the chat. So you have basically a bit of a part of a program, and you need to find a way that processes it in a very quick and fast way. And you only want to read in the first 50 lines of the data effectively. Okay. Yeah, hopefully it kind of makes sense how to use a if statement or for loop to read information from a file and kind of interact with that. And this is kind of the last bit before the next break. We're going to look at in a bit more detail. So how do we use for loops to process data files? Are there any questions until now before I carry on? I take that as a no. So yes, how do we say read in a lot of information from the data sets we've been using and sort of batch process them? So reading in a file name is fairly straightforward because file names are effectively strings and you can just put these strings into a list. Grouping over files. Say I would like to look at the GDP of Africa and the GDP of Asia. So I can define a variable or a list called file names. And say the first one is data Gapminder GDP Africa, and the second one is data Gapminder GDP Asia. So I need to define them as strings using single or double quotation marks, and you need to specify the path to your data in your computer for this to work. So I've now defined a list which contains two entries, which are two file names of data we have. So I can now use that list to loop over it, read information into a data frame, and get some statistics out. So a very simple for loop would be for f in file names, print reading file f, and then I read it as we would have read it before, pd.read csv f, and using my index column as country. And then let's extract some statistics out of this. I can say print min GDP is data dot min. So now within this for loop, I start reading the first file, which is the Africa one, because that's the first one in my list. And then I print out the minimum GDP for each year from whatever country that has the minimum GDP in that Africa CSV data frame. And I have the same thing for Asia. Sometimes you don't necessarily want to write down a whole list of just file names. So is there a way to access file names in a quicker and better way? The answer is yes. There's a library called glob you can use. In Unix, the term globbing means matching a set of files with a pattern, and that's kind of what we will be using. So there's common patterns to do matching, which means you can do something like star.csv, which would mean all files that have a name before the extension, but they all have to have the same extension of CSV. Or you can use a question mark, which means you need to match exactly one character. So how does this look for our Gapminder data set? So we start by importing glob, and then we can use glob to print all of our CSV files we have in data. So print all CSV files in data are glob.glob, and then just go star.csv. Oh. Well, here's a perfect example that the computer is doing exactly what I tell it to do, but not what I wanted it to do. So my current directory has no CSV files in it because it's the one with the 2 notebooks in it and my figure I created earlier. Instead, I want to look at my data directory. So I need to give it the correct path to actually return all the CSV files. And now what it does is give me a list of CSV files in my data directory. So rather than having to manually define the list of file names, I can use glob in order to assign the list. So I could say something like fnames equals glob.glob data star.csv. And obviously you again need to use the path for your data rather than my path. And if I now look at fnames, it has all the different CSV files we were given at the start of this. So now I can loop over all the data in the same way as before. So for f in fnames, data equals pd.read CSV, f, and then print the file name and data of the GDP per cap of 2007 and the minimum of that. And now the minimum GDP per capita in 2007 in the Americas is 1,200, and then in Europe it's 5,900. The overall minimum is 277, and so forth. Yeah, and with that, I think there's one last thing. Obviously, I could look at glob.glob for something else. So I can say data star.pdb. That list is empty, or WAV or something, that list is empty. So it will only return useful things where that matched pattern actually exists. Yeah, and now there's a couple of exercises around file matching and using glob to operate on many files. So if you take a look at this here, have a play with that, and then we will be going into a coffee break in 2 minutes, and then resume at 11:45 to look at how we can write our own functions. Are there any questions on this part?
Maybe I have a quick question.
Sure, absolutely.
Does glob stand for anything?
Well, globbing. So this is a
Okay.
Yeah.
Does globbing, does that word come from anything, do you know, or is it just what it's always been called?
Yeah, my Unix history is not globules. Okay, I don't know. My Unix history is not very good, but let's ask Google. Yeah, I think it's just, is there history? The origin, short for global, originates in the earliest version of Bell Labs Unix. The command interprets the early version, interpreters of the early blah, blah, relied on separate programs to expand wildcard characters in unquoted arguments. Blah, okay. So yeah, it's basically historic reasons would be the summary of this.
Okay, thanks very much.
All right. I hope you all had a nice little break. Before we get started, again, are there any questions about for loops, conditionals, looping over data sets, more glob things? Is everyone ready and refueled with caffeine or water? Okay, great. So yeah, the next topic, which is probably gonna take us, well, we'll see, probably all the way until we finish today, but we're gonna effectively learn how to write our own functions and in this way break up our code for it to do tasks repeatedly quite easily. And again, it's mostly, so if you have done any coding, you are probably aware of what a function is, and it's more what is the Python syntax for it. But yeah, let's kind of break it down how we can create our own functions, how we write maybe some documentation for it, and yeah, how that can then be used in an actual code you might be developing for an analysis or something. So functions. So the simplest way of writing a function in Python is by using the def. You okay? Is using the def keyword, and we can then give the function a name and say print greeting, and then use the round brackets, open and close, to give it the name. Later on, we'll put some arguments there, but right now this is just a simple no argument type of function. We have the colon again, and the same as with the if statement and the for loops, we have a function body which is indented by 4 spaces. So here we can just print hello in this function. If I now execute the cell, nothing happens because we haven't actually called the function. All we've done is define it. So at the moment in my kernel scope, effectively, I have this new function available to me, which I can run, but I haven't called it. So let's call it. So print greeting. So if I use tab, I can autocomplete it as well. And I will need to use the round brackets to be able to run it. Because if I just try and run print greeting, it will tell me that it's a function, but it won't actually execute it. So the round brackets are essential to actually run it, and all it does is print my hello, which I've defined here. So being able to print hello isn't super massively useful. So let's define a new function that can do a bit more, because you want a function to operate on data rather than just have a print statement in there. So for that, you can give function arguments, and the arguments go into the round brackets. So let's say print date, and for a date we need a year. And then let's define inside of this function a string that prints this to the screen. So joined equals plus slash plus string plus a slash plus string of day. And now we can say print joined, and we've defined a function that will print a date. At the moment, again, I've not executed it, so let's actually call this function print date. So it's 2020, it's March, and it's the 3rd of March. So I get this date printed. Now, I might naively think that, ooh, the month is March, and I will pass it a string, which does work, but it's lucky that it does, because I didn't necessarily know what is happening within the function, because I haven't actually defined what the different bits do. One way of doing it is you can set so-called default arguments for the function. So we can say something like year equals 2020, month equals 0, 1, and day equals 1. So we just always set it as a default value to the 1st of January 2020. If I now execute this, this will still work perfectly, but I can now also execute it with no arguments. I can also specifically say 1986 month is April and day equals 1. And again, it takes this information and replaces the default effectively. What might be nice is to give it a bit of a documentation string though. So typically what you do is use these 6 double quotation marks, and the R kind of means that you're using a restructured text. And we're talking a little bit about this later, but there's a standard way of writing documentation. I've basically going to show you the NumPy way of writing documentation. So you can give it a very brief name saying function to print date. And then I can define the parameters that need to be passed. And I say year is of type, well, int or string. Let's call it string, and it is the year to be printed. And then we have month, string, month for printing. And then we have day, there's also a string, and for printing. And then typically you would say a return, which we haven't defined yet what that is. At the moment, there's no return. So we can just say none, maybe something like this. So if I now execute, there's nothing new happened. I mean, I didn't change the way the function is defined or anything, but now if I type help print date, it will actually print the docstring information I just put in here. So I now have written my own help for the function I've defined. I think the next thing we should do is look at returns. So return allows you to give a value back to the caller of the function. So let's define a new function called def average. So this would be your mean function we've used with pandas. So basically we're writing our own version of this now. And we pass it values, and values should be an array. So one way of testing it is to make sure that we have more than 0 length of values passed in. So we can put a if statement here saying length of values equals, if length of values equals 0, return none. And none is the sort of special nothing in Python. So effectively, if we don't do this, otherwise the average would fail because we would end up dividing by 0. So an average is basically just the sum over values divided by the length of values. So we can use these built-in functions, return sum of values over len of values. And hopefully you know that dividing by 0 is not possible. So by putting in this if statement here, we make sure that we don't accidentally divide our function by 0. So ideally, again, I would define my doc string. I'm not going to do this fully now, but I'm just going to type compute average value of a list. And I can say A or AVG, the average equals average of, we'll pass it a list 1, 3, 5, 7, 9, something like this. Then we can say print AVG. What you notice is that I've actually assigned the return to a variable, and then I'm printing this variable. So that is perfectly fine to do. If we now see what happens if we call average with an empty list, average with an empty list, this if statement should get executed. And the function is not broken. So actually we need to print this. It tells us that the new average is none because here this if block was triggered. This is just sort of reminder that in fact every function does return something. So even if it only returns a none, that is a information you can work with. So if we go back to the print date function, we didn't really define a return because it just prints something, but we can look at the fact that it's still none. So I can say result equals print date, and then print result of date is result. And it will tell me that indeed it returns none, even though I didn't explicitly say this. Yeah, I think that is kind of your main way of writing functions. So you can make them as complicated and complex as you like, always with the goal in mind that you would want to really make a task you would want to do many times over and over and over again very easy to do by just being able to call this function. And this exercise section is fairly long and I think quite useful. So I will encourage you to actually spend some time working on this. If you could let me know when you're done with it or how far you get within, say, the next 20 minutes, then that is very helpful. But I would really try and I would encourage you to work through it as much as possible because it really puts all the things we've just been talking about together with the functions and the conditionals and the if statements and so forth. So I'm just going to paste that back into the chat. And also kind of does fun things of trying to help with how to deal with errors and things like this. Are there any questions around functions? Cool. So yeah, please do work through the examples, and when you're done, if you could just post in the chat, that'd be great.
Sorry, I have a question, and
sure.
I'm not sure. I just had a very quick skim over the examples, and it may be included in there. But what if we want to output multiple values from the function?
So you can return multiple values. Say, let's do a little bit of a cheat here. I'm going to copy and paste. Actually, I'm going to copy and paste this cell because I want to reuse some of this and don't want to rewrite everything. Let's call this new function statistic. And I would like to make use of NumPy, which we haven't really been using. So I'm going to use import NumPy as NP. So we'll leave the if statement and then say mean equals np.mean of values, and the standard deviation equals np.std of values. And then we could say return mean and standard deviation. And then I can call this function statistic. Let's give it some values. And now it returns the mean and standard deviation of that array to me. I can assign that again to a value. Or I can assign it to mean deviation equals statistic. And then I have my mean and my deviation saved individually. Or you can also return lists and yeah, you can return anything basically.
That's brilliant, thank you.
So you can put your return values in a list if you want, and then you make sure that once you return from the function, you extract the values from the list. But, yeah. So you need to know what's the first value in the list, what's the second value in the list, but it's probably better to return it like Tony did now as a tuple essentially, and then you can access those values.
Yeah, so we haven't really discussed tuples, but you could also return it as a dictionary. So you have a key and a value pair. Yeah, so I could just say, so I'm just going to add another, I'm going to say I'm also going to return values. So if I now look at value, the last entry is now a list, so value 2 is an array. Yeah. So you can basically return anything. What's the file not found error for the? Okay. How's everyone getting on though? I think I would like to resume in the next 3 minutes. Are you getting on okay with the questions? Are you okay to move on for the last 15 minutes? Was there anything in particular we should go over? Okay, I see some thumbs. Cool. Also, just a reminder, if you do have a wish list of things we want to cover tomorrow morning, please put them into the Etherpad so I can prepare this this afternoon and not be completely unprepared for tomorrow. Yeah, so I suppose for the last part, it's kind of small concepts that are probably quite useful to be aware of. One is variable scope. So this is always a bit interesting in a Jupyter notebook because it's different to in a script in the sense that a lot of information is just kept in the kernel, whereas in a script you might have to be a bit more careful to know what is in scope and what isn't in scope. And what do I mean by variable scope? It's effectively the values and variables that have been assigned that can be seen by the program at a given point in the execution of the program. So let's have a look at an example for this. So if I define pressure as and the 3.9 here. And then I define a function, adjust t temp equals t times 1.43 over pressure return temp. So this will work because I've defined pressure outside of anything. So this is known as global variable, and it is visible everywhere. So if I run adjust 30, I will get a return, and it doesn't complain about the fact that pressure was not defined previously. The variables t and temp are local variables that only live within the scope of the function, so within that execution block. So if I wanted to know what temp was, it tells me that temp is in fact not defined because it is only defined within the function adjust. And yeah, so kind of being aware of where and how you define variables is important. So if you use pressure as an outside global variable, but then maybe do something with pressure within a function where you actually mean to only use a local pressure, that might not be what you want to do. Pressure plus 3, so let's just execute this. So currently pressure is 103. If we run adjust, it now assumes that this is a local variable because you're doing something here, but you've not assigned it, even though in theory this pressure has been defined. So really what you would probably want to do is pass pressure in here. Oh yes, I do need this. So pressure, and now this adjustment inside can happen, but the global variable pressure has not been altered, even though the name pressure here and pressure here is the same as this pressure. You only pass the value, but you don't operate on that variable outside on a global scope, but you only operate on it within the function effectively. This can get a bit more complicated as your programs get more complicated. So being aware of what is accessible globally and what isn't accessible globally is important, and particularly in notebooks, because a lot of information persists between cells. You might accidentally end up with redefining the name temp for the 20th time, but the last time you did it way above, and then things break because you weren't careful enough with the choice of variable names. So being aware of the scope is important. And then sort of the very last bit is about coding styles, and kind of something I already touched upon when we were defining functions. but there are certain community standards, particularly if you write code not for just yourself, but you want to share it, that you should adhere to. So you might be working on a repository yourself where you define your standards, and there might be a developer guide that tells you how you should write certain things. You can just use a Python or general Python standard, which is called PEP 8. I'm going to share a link to that documentation. That kind of gives you a standard style guide of how to code in Python. And it's really useful to be aware of it. But sort of the main takeaway messages is that you should document your code. You should use clear, meaningful variable names, and use white spaces and not tabs to indent lines. And in general, I'm not sure if you are aware of white spaces. If you use text editors such as Sublime or PyCharm, they can actually show you hidden characters. So every space character is a hidden character. Every new line character is a hidden character. And making sure that your code is clean in terms of how many white spaces or so-called trailing characters you have is important, particularly if you use it together with Git, because you might end up with lots of changes in code just by adding lots of white spaces that don't actually change the code, but there's these hidden characters that make a code change seem a lot worse than it is. So another thing is so in terms of the documentation, I think I already showed you how to do that. So if you write a function, you would typically have a block like this that would contain your documentation with this is a one-line summary of your function, and then a bit more details on what the function does. And there are slightly different approaches on how to exactly document this. But yeah, I tend to follow the NumPy standard because I quite like it, and that's kind of what I grew up with. But I think, yeah, the whole point of this is mostly to be aware of that these standards exist, and you can pick something that works for you, and then try and stick with it. And then yeah, the other thing is you can test things within your your function to make sure that your program won't fail. And these are called assertions. So assertions are a very simple but powerful method to make sure that the context of your code is correct. So in a way, the if statement we had in our average function here was an assertion, because we made sure that we wouldn't accidentally end up dividing by 0 if our values array was length 0. So you can more explicitly define an assertion that would raise an assertion error if not true. So let's look at a example for this. So calc bulk density. You pass a mass and a volume into the function, and that function does something like return dry bulk density, and the bulk density is mass over volume. And now, would it make sense to have a 0 or negative volume? No, probably not. That would mean that you're giving the function something nonsensical. So you can insert an assert statement here and say assert volume is larger than 0. And if that isn't true, the function will not be happy. So let's run this, say the mass is 10 and the volume is 25. It will return my bulk density, but say I set the volume to 0, it will raise an assertion error saying like, no, you've given it something silly. And in order to define exactly what mass and volume should be, parameters, you can set them here. And say things like volume float value greater than 0 value. So you can explicitly state what is expected in your doc string effectively. Yeah, so in terms of the material, there's some examples where you can have a go at documenting something, but this is probably a good at-home exercise. Also because we are now reaching the end. So yeah, this kind of brings us to the end of the general Python section. So far, this is kind of the whole content of the Carpentries lesson. What we're going to do tomorrow is have a play with not running Python in a Jupyter notebook, but actually run a script, and also look at some of the questions you've raised, or your wish list items, to see if we can discuss some of these before moving on to the next topic. So yeah, in general, as a sort of recap, there's very many resources on Python out there. This Carpentries course kind of basically just scratched the surface a little bit. There's vast amounts of documentation, both on Python 3, on various different packages such as Pandas, NumPy, Matplotlib, but also how to use the Jupyter project. And you can assume if you have a question, someone else probably had that same problem before you, and you might find a solution, particularly if it's around how to write something in a specific kind of syntax. But hopefully you've got like a nice overview of functionalities, basic functionalities in Python, and how you write things like a function or your for loops and if statements, how you work with quite a high level library in Pandas, how to do some plotting there, and how to manipulate the plots. And I think my general advice is if you want to actually start using Python, the best way is to find a little project and do that in Python. And even if you are 3 to 10 times slower than you would be in MATLAB or something else, it's a matter of trying it out and playing around with it. That's the best way of really learning and improving. Are there any questions for today's session, about tomorrow in general? Because effectively this is us for today.
No questions, but thank you very much. It's very useful.
Sorry, you're breaking up there a little bit. I didn't understand that.
Just before you disappear, can you please head back to the Etherpad document and give us some feedback for this half day, line 248, please? Link is in the chat. So again, like previous days, things that you liked that worked well, and then some things maybe that require more explanation.
Yeah.
Thanks very much, everyone.